Okay, that is us live. And why is there no image there? Okay, let's try full screen. And I guess I'm hitting the wrong monitor. Oh, that's right. I I grabbed Mark B's setup. He's probably got different monitor setup. Oh, wow.
All right. I can
Yeah,
verify that we do have audio.
excellent. Now I just got to make sure I get the right screen on here.
Yeah, verify audio on YouTube.
Okay. Play once. That one. Okay, there we go. Okay. Hey, look at that. Okay. Hey, everybody. Sorry for the futzy issues. We're having audio problems. And it sounds like we have audio now. And yes, I'm using the uh, CoCo Nation template stuff because I hadn't set up one for this event yet. But we're going to start with the first person, which is Rick Ulland. Hey, Rick, say hi.
Howdy, folks.
Hey, there's Rick. Okay, so Rick, let's get this turned over to you because we're burning minutes. So I'm going to go full screen here and go for it, Rick.
Okay, I'm not going to see any of this because I didn't bring up a browser because it will make my computer fall down. So let's just go right into it. So I guess first, what the heck is CoCoIO going for? We aren't really a content provider like FujiNet. We don't have anything to offer yet, although someone might do that. But it's also not just an Ethernet chip because that falls into the weeds of trying to get the CoCo to do the housework rather than actually get something done. So I guess just think of it as a software driver, and you're about there. You'll be wrestling with the on-chip data buffer, which is a ring buffer, nice funny little boundary things, but you've got 16K to split between transmit and receive, so you can do things at the speed of the WizNet, not the speed of the CoCo, and then kind of collect things off the buffer when you're done. So that's somewhat helpful. Let's see, we'll go with, if I could find the right way to get there. So our interface is basically this 4 bytes, which fits into our I/O space pretty good. There's a command register that you only touch when you're setting the chip up and never again. And then there are two address bytes that will write into the chip itself. There's 32K inside that chip, and basically you're pretending like it's a software driver that you deal with. And then there's a data byte, which has a auto increte feature where you can just keep banging bytes to that same address, and they will go to sequential bytes inside of the internal buffer, so you don't have to do a lot of resetting of address and so forth. Kind of handy. When you go through the WizNet examples, they're all for Apple, so everything's the wrong Indian around, and they keep talking about flip-flopping bytes and so forth. Just straighten everything back out, and it works just fine on a CoCo. Let's see, I'm getting ahead of my script here. So this is what we actually have. We have command registers. The common registers at the top are for the entire chip. It's your local IP address and gateway, stuff like that, that applies to everybody. And then there are 4 blocks of socket registers. We have 4 allowable sockets, which is, it's kind of handy. They're spaced exactly 100 hex apart. So when you're going through code, if you see that first address you byte to is a 4, 5, 6, 7, you know which socket you're writing to. You don't need to get out of try or anything. And then the same address is after that. Let's see. So here are those common registers we were talking about. So you put in a gateway address, a subnet mask, a source hardware. It's almost like you're setting up a driver. Your local IP address, we'll get into some of these things later, but basically, then you have the sets of socket registers. Since you have 4 allowable sockets, you're doing the same thing 4 times. Not every socket has every feature that's mapped into here, especially on the chip we're using. So for instance, there's no raw mode in socket 3, although there is a place to set raw mode in socket 3. It's just going to fail. But nice and consistent, so you don't have to change your code between things. And I'm not leaving any time for questions. Just butt in, because like I say, I'm kind of winging my way through it right now. Let's see. So these data buffers again, we've set up our stuff up here, the socket registers, the common registers. That was our config section. And what we're left with is this 16K of data space. There's AK in, AK out. You can split it 4 ways between the 4 allowable sockets. So that lets us just, the chip will hold our data and send timeouts and wait for us to empty out our little buffer and tell it to proceed again, which is a very handy feature on an old slow machine like CoCo's or Apple II's, and the other things that we've been using. So I guess we should just kind of, people wanted to know how to start the chip. So let's do a really simple code example just to get in and try to be less obtuse. And so what we're going to do, basically some CoCo 3 stuff you can ignore if you want to use CoCo 2's, but HTML is basically an ASCII protocol. And to get a web server to talk to you, you send it a 4-line header that MS-DOS ended. So what we've done here is we've taken our 4 lines and we've read them in and thrown character return line feeds at the end of every one. So we've got one string that we can just dump out, and that should wake up a web server. We've set up our 2 data buffers to use for our first socket here. And then we're off to, let's see, where are we off to? Filling in our config chart, and this is a demo. So we're going to ignore everyone else, reset the chip, and just bang right into it. And then we're going to start auto increment, so we don't have to write an address for every byte we write to the chip. We can just sequentially bang FF6B over and over and over until we get to the end of the line.
Hey, Rick,
Yes.
I'll be looking for questions, but you might want to mention that the way this is implemented, your device is mapped into the CoCoIO is mapped into the memory space, IO space, but it only uses 4 bytes.
Yeah, that was this guy.
Okay. You did mention that.
Where
Okay.
are we? Yeah, we start here. This is all we got,
gotcha.
folks.
Sorry.
We have a master command at FF68 or 78, and then we have 2 addresses into the chip at X9, XA, and then we have a data register with auto increment, so we can just keep banging on that data register. So TFM works really good going into here, I would expect. I'm not man to write it, but I would expect that works really well.
So if you're going to set 1 byte in the configuration, say the ping timeout or something, there's a data byte D that you want to put at address A. How do you use those 4 registers to do it?
Oh man, you're going to make me think. I'm ill, man. So we have the master command register, which sets the chip the way you want to go, and then from now on, let's just go through the code.
Yeah, that's pretty. Oh, okay. Yeah, you go ahead then. Sure.
That'll probably cover us. Now where are we at? So anyway, into our config chart, we reset the chip and we set auto increment in indirect addressing mode because that sets our 4 bytes, which is the only physical interface we have on this chip. And then we basically run through that config ladder here, just poking everything. The first part of it, we have to set everything, so we just kind of stream it all out. But then we get into skipping amongst the remote config. We're leaving most of it default, so you'll notice we're setting the address now every time to where we're writing into the config register on the chip itself. Once we set that master mode, we're kind of done there. We're going to run in this mode the rest of this example anyway, so I'm going to keep it to what I understand and stay there. Let's see. I should have ran through this before I ran through this. So anyway, we're setting up an individual socket. So here I'm telling you that it's the 4, 5, 6, 7 will be the 4 sockets that you have. So it's pretty easy to go through the code and keep straight what you're poking into, just because of the starting address is an even 256 bytes apart.
Yeah, so that line 1310 actually is like an answer to the question I was asking. First, you poke the high address at 69, and then you poke the low address at 6A, and then you poke the data at 6B.
Which
And
incidentally is our way around, unlike a lot of the Apple docs you'll read that say, "Oh no, you've got to flip things around and think differently," and it's kind of funny actually. But
this is think straightforward.
That's only because the WizNet is big Indian, and so is the CoCo. And the Apple
Right,
isn't.
right.
So half the code is all gyrations.
well, yeah, and all the sample code you'll ever read is written for the Apple, so just keep it in mind.
They've been doing it since 2015, so it's well established. Lots of examples.
Exactly right. In any case, so the first thing we're going to do as a local command is try to open the transmit buffer, and that should just work. So we don't need a loop or anything. It either works or it didn't. So, and then we try to start a remote. And I think I've got a bug here where I'm actually opening the socket again when I shouldn't be. But in any case, it worked for the example, so it's still living there after all these years. Let's see, where are we at now? So if we do have a good connection, then it's time to fill our write buffer. I'm having trouble reading my script and following the code at the same time, so I guess I've got a one-track brain here. Let's see. So let's go to next step. Pointer math, and here I'm really lost. Henry can probably tell me how I've screwed this up in many different ways. But it's a ring buffer, so you have to figure out your start address, your end address, roll back around to the start again if you roll past the end of it, which the first time through, it's simple. It's going to be 0. So my little DECB example worked fine. Let's see. So anyway, I wouldn't trust my math at all, but this is the kind of thing you have to do. They provide you pointers to the start and end of the buffers, but the chip doesn't itself manage that. You have to track those pointers and okay, it's time to start back at the beginning again. And I've not done any of this because all of my code blows up at the end of the first load, I'll be honest, because I'm more into hardware. Anyway, so we've sent our request to the web server, and we're simply waiting for a reply. We're going to make one critical assumption because this is at basic speed. We're going to assume that if there's any data in the buffer, it's full. It's 1,500 bytes or so, but that's running far ahead of us. So we're just going to assume that data's there, it's full. We do some math to determine if it's all in one block or split in the middle, but I'm sure I'm not doing that right because I've never got it to, work properly. But again, this was my proof of concept, so I'm really working this up, ain't I?
Yeah.
Anyway,
My experience with this kind of code is either it works right or it doesn't work. And so,
right, and this
you know
works
when
right,
you got it
so
right.
it does in fact work. So anyway, let's see.
The failure mode is like when you get to the end of the 2K buffer, you don't wrap around correctly, or
Well,
something.
exactly, because you
Stops
will
at that
blast. You will blast right into the next socket's buffer if you're
Things like that, yes.
if you're one of the earlier addresses. So WizNet will let you blow up any way you want to blow up.
Hey, it gives you freedom. If I remember right, if you allocate the whole 8K, it'll automatically wrap back. So if you only have a single task, you can just grab the whole thing. It should be.
Well, yeah,
easy.
and there's other tricks that you can play, and that you can use the buffer for storage. Like you could dump a whole game map onto the CoCoIO, but only use little bits and pieces of it. So you don't have to use CoCo processing to move the 8K. You just use it to pick and choose amongst it. Anyway, I had a demo, but I blew it up, so I'm not going to show Deck B loading CoCo, but it has happened. And I'll try to fix that. I also got GitHub links, so you can try to blow it up yourself. But then I wanted to get into not the basic chip, but more of the OS level stuff. And we're again in kind of in the middle.
Hey, Rick,
Yes.
Curtis had a question. Yeah, he said data register is single 8-bit value mapped into IO space. Yeah. He said also, he might have missed this earlier. Is this interrupt driven in any way, or is it polled?
We have interrupts available. Not from Deck B, obviously. So this little example has just been timing and looping. But you will get a cart signal when anything changes on the chip. So
that's if there's stuff in the incoming buffer, or if there's what is it trigger on?
Have you played with that at all, Henry? Or
yeah, there's a number of things you can ask for interrupts on. You know, if the TCP connection drops, when it's available to send more data out, when more data has arrived. We have not been using that. And none of my OS 9 code uses the interrupts yet. But then we haven't written proper device drivers. We've been doing it our own ad hoc ways from user space.
Right. And in my case, everything I write is so slow. I just look at the data buffer size. If it's greater than 0, we're done. You know, it's just a stupid little loop because, like I say, I'm not that sophisticated either. So in any case, here again, we are halfway between raw nothing and complete utilities with Henry's utilities, which give us pretty much the basic functionality without all of the nice bells and whistles wrapped around it. So it gives anyone who wants to play with CoCo networking a lot of room to play, and we'll get into that in a second. But what he's provided for us is really handy. FDHCP will return the IP address, netmask, and gateway from your local router, so you don't have to do the manual effort of finding out what's available and assigning yourself an IP address, yada, yada. Otherwise, fconfig, if you know all these things and you want to set it up quickly, that will accept those values and get you online ricky tick. Then we have the two basic ping and ARP, so you can find out who's on the network and what their actual MAC address is, which doesn't change, unlike the IP address that might change. So that's kind of a handy thing to know. Let's see, dump, tget, send. I mean, you could pretty much write a TFTP, couldn't you, using these? Just kind of little syntactical stuff around it. So again, it's not done, but it's certainly get you there. There is NTP. As far as I know, it's only Greenwich Universal Coordinated Time. So if you're running OS 9, that's fine if that's how you run your clock. Otherwise, you might need a little wrapper to bump the number. And dig, because you can't do anything without getting people's names. So here's the very basic dig. It will succumb to C names and other stuff. So again, you get to write a little wrapper to eat the C name and try the subsequent address and until you get a proper A record. Let's see, I guess what I've done with these basic commands to make OS 9 easier for users, we're starting with the kind of a familiar config here. So I stole everything from Unix. This file will let you just specify your hard-coded addresses if you have them. It will also let you specify DHCP temporarily and leave all of your hard-coded addresses stashed underneath, and they'll be ignored. So just kind of normal Unixy things. I did throw the physical address in here, which I haven't really written in yet, but that's coming soon. OS 9 near you. Um, let's see. If I run it on the CoCo, well, here's the interfaces file on my actual CoCo. And you'll notice it says DHCP here. So if I run it, we'll get completely different numbers because I'm on a completely different network. So I run my handy little ifconfig utility, and it comes back with what we actually got. And that's what the WizNet is loaded up with for the duration of the run. Let's see. Oh yeah, I got a little network tip here. If you've done this and you've gotten these strange numbers and you're going to keep using this router, just put these in your router as a hard set address and use it as if you had. Because the router is going to keep this reservation for you under this MAC address until it's reset. So you can save a lot of time waiting on the CoCo to DHCP itself in by just setting the numbers hard-coded, and if it breaks, go back to DHCP and see where you were sent to again. So a little bit of a CoCo tip I found during my testing here. Let's see where we at. Oh, we went to static, and it did what we had typed in because that's what we told it to do. So that's fairly straightforward. These are all the live demos that I can't get working right now. So we're going to finish this segment up in like 20 minutes. So be thinking of some questions, boys and girls, because I'm going to need some. So the next thing we did was stole from Unix was hosts. And this is used for a couple of different things. The first couple of lines are sort of a local reference to ourselves, since we only use DHCP, the first 4 characters for DHCP, I believe, Henry. This would just be Rick and Port would be the 2 machines that showed up on the router. But that's all good. And then we come with the section of hard-coded IP addresses. We aren't going to ask about these. We're going to assume we are right and everyone else is wrong. And so these next 3 are hard-coded, and I'm pretty sure Play Classics was never right because this is a typo. So it's not the new address or the old address. It's just some random address that got typed in. We'll post the correct ones.
Sorry about that. The server had to get changed, but it has a different IP address now. Do you want the correct IP address?
Sure. Yeah, let's put it out there. So
Okay, I just gotta ping it here and see what we get.
where am I this week?
So it looks like it's currently, and it is a static IP, it doesn't change. It's 104.254.247.197.
And I believe that's fixed on all the GitHub examples in my code. It's just not in this.
And it's one.
I had to pull this old video out because my demo's broken.
The curse of the Microsoft demo.
Well, I had to change something at the last minute to make it better because I'm an idiot. So anyway, I did that. So you have your self-referential lines here. You have your hard-coded addresses. And then I've stolen a bit, and I'm making a DNS cache right in the host file because why create another file? So everything under this comment, which is legal in Unix, I guess, so we still haven't broken the mold completely. These are all things that we looked up with FDig. And FDig will look for an address. It may come back with the C name instead of an A record. These are all technical crap, but here we go. If you get that C name, then you look up that address. And if you chase it far enough, you will probably end up with an actual A record that we can write here. So next time we look up Google, we won't go through the 17 steps to find its current address. We'll use this till it breaks. And once it finally breaks, we'll delete it and do a proper search again and write a new cache entry. So that's my master plan for OS 9. I actually have, let's see, examples of this, I think, here. So yeah, we might, and I'm going to try to go through it because my script probably doesn't match the slides anymore. So if it sounds really stupid, just yell at me. So where am I? 40, 40, 40. So what we're going to do is start a read loop and what am I doing? Oh, okay. So first we've got to go through the interfaces file and find our interfaces and set them up. We're just parsing that. Then we have to jump to hosts and get our local name and short host name. It starts out complicated, but it's actually easier in the end. Now we're going to, man, I should have read through this before I started. 44. So if there's a name in host, we've got to do some ugly string slicing to get our name. We're getting the first 4 characters that are available to us, left string, f host. And this is all working towards starting up the interface without the user having to do anything. Let's see. And again, I do apologize for being so disorganized. I'm running kind of light on sleep. Anyway, so we have to start a little bit of because the way the Unix files are parsed, you can't just assume that you can run down the file and read line by line. You sort of have to recursively go through it and pick out data that may come at you in random order. So that's kind of what we're doing here. We do a loop. We start looking for items in the loop. If we find them, we assign them in whatever random order they might come up. And continue doing that until we get to the end of the stanza that we're working in, which is white space separated. And, you know, we're trying to emulate an actual Unix parser without spending a whole lot of time and money. And so this is how we're doing it. You just go through, and this stuff might be in random order. You might have more than one interface, so you have to account for, you know, going through it several times. And so, yeah, if we do run into the start of a second interface, then we're done. You can assume that, yeah, your random order doesn't go beyond that. So now we've loaded, we've set all the variables from our hosts and interfaces, so we have enough to set up the CoCo, and we can just ask Henry to do it for us. So here we're either sitting in fconfig or fdhcp, depending on what we got out of the interfaces file and what we parsed out of that. And so again, we kind of transparently got there, or we blew up. Let's see. I think, is DHCP always still in debug now? I believe it.
I wasn't aware of that. I don't know.
It may be. In any case, I don't know how to turn it off, so I just kind of eat the debug stuff. I don't know how to get data back from an external program once I've called it with the shell command. How do you get it back into BASIC? So I made a temporary file. That way I can just read my temporary file, and I know that works.
That's not a big error. A lot of people do that.
I'm sure there's a way to, I think there's a way to do it, but once you've called a shell, I can't get it back upstream into BASIC 09 again. So anyway, that's what we've done. We've written a temporary file that sits there. And then we have to, one last file. We need a third config file that I stole from Linux, which is resolve.conf, which lists your name servers. So I guess here's Google and Cloudflare. And we do define end dots. If there's at least one dot, it's a full domain name that you're asking for. So google.com is a complete domain. And you don't, yeah. Anyway, it's that's the only option we have there for resolve conf. But that completes our stealing from Unix for the moment until something else comes along. So anyway, those 3 config files, if you know how to edit Linux or Unix, you know how to edit them. It's the same. You don't need to find a CoCo doc. It's the same old stuff. That was my thrust anyway. So now where are we at? We are moving on to, actually doing the DNS name server tricks. If we do need to look up a name, then we again do a data file, write a temporary file, copy it back, remove the name that we had to replace, put in the new name. Just pretty simple file mangling there, so not much to talk about other than it again keeps your host file current as you move along. This is all on GitHub, so if you really want to follow it better than I'm mangling this explanation now, that would probably be the way to go. Let's see. Then, what else have we done? Oh, yeah, I stumbled across this basic 09 trick, which I've never seen before. Normally, you have to dimension variables and give them a specific type and yada yada. But in basic 09, you can just use a string as a string, just out of thin air. It's not dimensioned, it's not specified, but it works.
I think it's a default of size 32. Is that right when you do that?
It defaults to some kind of string. I assume
Yeah.
a string 32.
I think
But,
it's 32. I shouldn't. I usually don't speak when I'm not certain, but you can dimension it to be more or less to manage your memory.
Well, you can dimension anything. It's just weird that you can use a variable that wasn't dimensioned at all.
Well,
That's completely not allowable in Basic 09, as far as I know.
String your variables are by default float. You can use float variables too without dimensions.
Oh, okay. And a string and single letter strings without dimensions.
Mm-hmm.
Okay, because I guess using Basic 09, my emphasis has always been on its sort of database capabilities, so complex data types and addresses, 15 different strings that I can put as one item under a disk file and so forth. So I never really knew you could do that. But let's see. I'm going to close with this demo, which recap. That should give us the CoCo booting up. Now, this is someone we haven't talked about. The very first contributor to CoCoIO was Michael Furman. And his concern was the real-time clock, because everybody's worried about our real-time clock. So let's load some minimal fonts and pointers, which, you got to sit through. Be glad I'm not loading the whole 147 fonts and all of the things that you can do. 5, 4, 3, 2. And here is NTP date, the little utility he wrote, which has determined that we are at 10:39. And we've got 40 minutes left to kill.
No, you don't. At 10.
Oh, okay. Well, in any case, things are still working. I wish I hadn't tried to fix my www demo because it's exploded and I can't get the web browser working right now. I'm sure I have videos of it, but they're useless. So, anything we can see. One moment.
Curtis says, yeah, undeclared variables become reals if they're numbers and 32-byte strings if they're strings.
Okay.
Okay, so just the A dollar sign becomes a string, even
Mm-hmm.
though that's not normally a pattern you would use. Strings are just a name that you've defined as a string. They
Exile
don't
in
have dollar
Paradise.
signs.
Exile in Paradise asks, what's next for CoCoIO? I think it's world domination and stealing your personal data.
Yes, yes, yes. So my actual physical next step is we're replacing the jumpers, like the right jumper and the address jumper, with a register. So you just write to the register, set your mode, set your address, kind of like a more modern interface card. The jumpers are just too futzy, you know.
This is on the CoCoIO R, which got the ROM on it. Or
Oh yeah, with
Flash.
the with everything going forward, we'll go with the
The ROM.
bigger, yeah, with an actual buffer for the settings and a little bit more smarts, so we can do. I mean, I ran out of gates basically on the old 16v8, so we bumped it up to a 22v10. I'm still resisting using a real chip. Actually, can't afford them, but we won't get into that. So anyway, with the extra stuff available, we're able to set up a register, have 8 status bytes or bits there, so you can turn the write mode on when you want to write and turn it back off when you're done writing, and not ask the user to have to do anything. Um, Other than that, not really much. I really want to work on the server side now, because I'm not the guy to write CoCo code. Basic '09 is kind of my limit. The little dub demo thing was about as far as smart as I'm gonna be. So I'm looking forward now to the server side, which I'm more familiar with. I did a lot of Apache and Nginx stuff, so I can probably come up with things for the CoCoIO to talk to now. Would be the next thing that I want to accomplish, because we're limited. The world has passed us by. It's all HTTPS. We're not going to decode that on a CoCo. I've been playing with little decoder chips. There's no way in hell. So we're going to need. So what we're going to need is a proxy server. We're going to need some place that the CoCoIO can log into that will get all of those secure sites, desecure them, and pass them on to known CoCo addresses. And that way we can do stuff without the user having to mount some local server on a local PC and yada yada. I want to keep this. You need the ROM pack card and hook up to your cable router, which Henry's done a lot about with the whole boot ROM and the Axiom. Which, if you'd like to say a few words about that, I would love to hear it, because that's a beautiful project and not enough people are using it.
Are you capable of booting one up right now? Can you plug a CoCoIO into
Sure. Let me give it a
World?
whirl. I'm sure we can get this one going. If you can excuse me for 1 second here, I will be right back.
Okay. I've got while he's gone, I've got a slightly different answer to your question, Mark. What I would like to see is real-time networked games. I brought one to CoCo Fest last May. It was using UDP broadcast with fairly small packets. I think like 24 bytes once a second, sent out to the other players. And we were playing a live space war game with 4 spaceships on everybody's screen shooting bullets at each other. And since that was using UDP broadcast, it'd be nice if it had a switch so that it could use either UDP through a reflector on the internet, and then you don't have to be on the same LAN, or it could use a TCP reflector on the internet to get the packets distributed to everyone. And I had to cringe about a month ago when Nick Marentis said, what's the best way to write networked games for the CoCo? Is there an easy API or something yet? And my last 2 months, maybe 3 months, have been very unproductive as far as CoCo wise, just because of personal things, interfering with my CoCo life. So we're not there right now. But I really want to, by May, or even a month from now, have an answer for him. And it'd be great if it had adapters for Rick's card. It'd be great if it had adapters to use the FujiNet. And I've even got another networking project that I'm secretly working on right now, but I'm hoping to have a network card for really cheap, like $20 or something.
Cool. We got a CoCo Nick also that Jim.
And the CoCo Nick, yeah. So I think if you looked at my Space War networked game, you could like draw a circle around a couple of functions and say that's not a bad API right there. You could write a lot of games using just that. So that's my answer to your question. All right, now he's running. That's the boot ROM I wrote called Axiom, and it found the WizNet chip. It's doing DHCP. It found a server, and it's got an address, and now it's dialing into a server that I run on the internet. Oh my gosh, I hope it's up. Well, it's a shame if that's the end of our demo right there, because that server should come back and present a menu of lots of different things you can do. Okay, we'll try again. Let's see if it can connect this time. Okay, we got address 130. There we go. Okay, so after Axiom, the boot ROM runs, then lemma is the name of the code on the server. And it's called lemma because it's not your end result. The end result is not to run code on a server. It's to run code on your CoCo, and this is just a step to get you there. So there are OS 9s under menu number 30. I kind of used a video text model where you type in numbers to go to frames. The stress tests are the games of life. And well, depending on whether Rick's got a level 1 or a level 2 machine, is this he can, okay, now he's gone to the life viewer. Do number 13, life viewer with statistics. And then he types ampersand to launch the code that's on that page. And I see a frozen screen. I guess the card crashed or something, but you see the start of a game of life. Anyway, all that code got loaded. No, I'm sorry, this is not code loaded. This is the CoCo functioning as a video viewer. The code would actually run on the server that plays the game of life. But and we did this not to, the main reason is we wanted to stress test the CoCoIO card with that. What does Rick want to do next? Okay, we'll try it one more time. Launch number 11, all right. Not a number. Now we got it. Oh, I don't know where the problem is. Sorry, Rick. Try launching an OS 9 then.
So Joel Eby, I think it is, said he's had good luck with an HTTPS proxy called Web1 for accessing modern websites using vintage browsers. So it sounds like there's people already working on proxies. That's good.
Okay, that's good. Yeah. Uh-huh. All right, let's make one more attempt. This time do menu 35, Rick. And let's, because this is something I did not have running at CoCo Fest last year, which is to get into HDB DOS. Try 35. Okay, 351. That looks like hardware problems. Sorry about
Yep,
that.
it does.
So the this one that we just attempted, what it should have done is it should have displayed the big disk tree that comes with the SD card for HDB-DOS. Was a huge tree full of basic programs and other things. Let you navigate through that tree, mount the drives, run a program. You can run the address program in there and save your address book out to a file on that's based on the internet, and then go open it and read it later. So that's how far I got with that.
Oh, I've been muted this whole time. Well, that's helpful.
Yeah, sorry.
No, I muted myself. Let me grab a different one. I just grabbed this one off the workbench, and it's probably broken. Tried.
We're down to 3-4 minutes, Rick, so
Okay.
you'll have more time at CoCo Fest. Everybody show up.
That's
May 2nd and 3rd.
Yeah.
We'll run Space Wars again.
All right. We are back. Very different. Oh, I don't even have the camera on. Perfect. Probably a good thing. This guy. Let's go with.
We have Joel in the wings for his presentation on the DS69B video digitizer coming up in just a couple minutes, believe it or not.
Sweet. We're going to try this demo again with another random chip off of the desk. I'm going to go to the live demo again
Okay.
because that's easy and quick. And
And that's a diagnostic tool. So
Rick, you're not supposed to admit it might be bad hardware. You're supposed to say, well, it worked in testing.
well, it did work in testing. Fatal. What? 4020. What is a what?
that should never happen.
We did a what? Cool.
Well,
I've got
it did.
all kinds of- Oh, I know what's wrong. I know what I need to do, folks. I need to get rid of the SDC, floppy controller. Let's simplify the program here. I have many competing things on the strap multi-pack that could be causing some.
There we go.
We're going to try it, and if it doesn't work, we die. Oh no, thing's not even powered. Here, I should turn on my camera and share my pain with you. Here we are, trying to get this thing working. You go ahead. Multi-pack on, CoCo on. Nothing. Okay, well, luckily we have 69 digitizers in our future. Huh. Nice concept.
Yeah. Yeah.
Moving right along, Rick. About ready to grab the big hook.
Just put it in raw. There you go.
There we go. We're going to give this a shot, and if it doesn't work, we're done. It doesn't work. Okay, well, I don't know what I broke,
Sorry, folks.
but as we've noted earlier, I broke something.
All right. It will be working at CoCo Fest.
We will have
Indeed.
multiple CoCoIOs there. I have one as well. So
Yeah,
there'll be
good.
lots of hardware to bring and show off.
Oh yeah, I got all kinds of errors. Now I got a fatal no-whiz. Cool. So yeah, I guess I'll quit running through broken hardware right now because it's obviously not going anywhere. I'll be very happy to watch the DS69 coming up, and we will have things going by the CoCo Fest. I hopefully have at least a demo of the new card. I don't know if it's going to be in production by then yet because money. But I'm hoping to get rid of all the flip switches and have some state on board and stuff like that. So
By the way, Rick, Wingnut says that's Ron from Delaware, if I remember right. He says, sorry for what? The fact that you got that far is a huge accomplishment.
We got far enough to break it and still have something running. So yeah, I guess that is an accomplishment of sorts. Oh, I never even finished the script. It wasn't saved. That explains a lot. So anyway, project's not dead. Chips are still available. We've moved up to a newer firmware thing, so that's no longer a problem. And
Okay, well, I'm going to call this segment a wrap. Thank you, Rick and Henry, for being on. We'll have Henry on later today where he demos his
good stuff.
cool new 6809 or 6309 system with Nitrous 9, hopefully. But in the meantime, we have Joel here in the wings to bring up his digitizer. So I am going to, yeah, I think I'd like to stop the recording in the stream so these are all individuals. So we're going to sign off, but we'll be right back momentarily.